Graphing rational functions. Here we go. The vertical and horizontal asymptotes are where this starts, and I'm hoping this is what we get through today, is vertical and horizontal asymptotes. Okay, so now to define these rational functions, they are different than reciprocal functions. Reciprocal functions from 8.3 had 1 as its numerator, or some number. Right, 1, 2, 3, 4, whatever. It was a number in the numerator. Yes, Miss O'Neill?
Are you videotaping?
I am.
Okay, great.
I am live and in living color right now.
Woo.
Okay? Great. The difference here is that your numerator is also a function. Okay? So now you have functions over functions. Polynomial, whether they be linear, quadratic, cubic, whatever they may end up being. Typically, we'll stay with those 3. Occasionally, maybe a 4th power polynomial comes into play. But typically, you will stick with your linears, quadratics, and cubics. The problem is, they'll be on top of each other. Okay? Now, the main reason why I'm doing this in person and not on video is because there is a very, very specific step-by-step process that I want to see you guys take with this, so that way you're not overwhelmed with any one problem. Okay? If you take these slow and you do it this way, these are not as bad as what I will make them out to be. All right? But this paragraph here is important, okay? In order to graph a rational function, it's helpful to locate the zeros of it and the asymptotes of it. You do those 2 things, you'll get a general idea of where the rest of the graph is. All right? A zero of the rational function occurs at every value of x for which a of x equals 0. If you notice, a of x up here is the numerator. Okay? So that's important. Your zeros happen where your numerator equals 0. All right? So make sure you know that. If you're going to make like a highlight point slide thing or whatever, that needs to be there. Okay? Your zeros are where your numerator equals 0. Questions so far? You don't. Everybody good? Okay. We're going to go through this part by part and dissect it, okay? Slowest one I ever do with this. Okay? If the function is a of x over b of x, a of x and b of x are polynomial functions, no common factors other than 1, and your denominator is not 0. All general stuff, right? Okay? You have polynomial function over polynomial function. You can't cancel anything out between them, and your denominator is not 0. Okay? That's what all that says. Everybody good? Okay. Then you have basically, it looks like 5 bullets, but essentially you only have 3. Okay? Then f of x has a vertical asymptote wherever b of x equals 0, just like last time. Right? Your vertical asymptotes happen where your denominator equals 0. O'Neill?
Can you go over polynomial functions?
X to the third plus 2x squared minus 8x plus 7. Okay, just like I know it's been a while, but chapter 5 stuff.
Okay.
All right, cubics, squares, whatever they may be. Okay. That's part 1. Part 2, and this is the important one. F of x, your function has at most 1 horizontal asymptote. Okay, at most 1. To find that 1 is a little tricky. Okay, because now you have to go into like your what if cases. Okay, so case 1, if the degree of a of x, which is the numerator, is greater than the degree of b of x, which is the denominator, okay, see that? Then there's no horizontal asymptote. Okay, so if you want to like write these off to like the side, I don't have enough room up here, so I'm only going to do it like this one time. But do something like degree of the numerator is bigger than degree of the denominator no H asymptote. Something like that, just so you know. Okay, like I said, I'm not going to do it for every single one. I'm going to do it for that one. Mitchell.
So basically it's saying that there's like an x to the fourth on top and x to the third on bottom.
Correct. Correct. Okay. And to be honest, that one we'll mess with it a little bit today, but there's also a special case hidden within this one that if I have this planned out right, we won't get to till tomorrow. Okay. Everybody good so far? All right. I'm going to get rid of all of this stuff, okay? Because like I said, I'm not going to clutter this slide any worse than what it already is. Okay, second bullet. If the degree of a of x, which is your numerator, is less than the degree of b of x, the horizontal asymptote is the line y equals 0, which is the x-axis. Okay. So if the degree of a of x, the degree of your numerator, is less than the degree of your denominator, your horizontal asymptote is the line y equals 0, or your x-axis. Everybody good? That's case 2. Case 3. If they're equal, then the horizontal asymptote is the line, is the line y equals the leading coefficient of your numerator over the leading coefficient of your denominator. Okay. So now if you go down here and you look at all three of these examples, let me get out of draw mode so that way the logo goes away. There we go. If you look at these three examples on the bottom of your slide there, and this is also why I print them out for you. First one, you have x squared over x plus 1. X squared is the degree of 2, x plus 1 degree of 1. Numerator is bigger than the denominator. As you can see, there is no horizontal line that these two graphs, or this graph in particular, that the two arrows of it are approaching. See that? You have this one that kind of spews off top, and then off this way, and then this one down here spews off bottom, and then down this way. There's no horizontal line that they're like approaching together. Okay, O'Neill?
So will we be able to just figure this out just by looking at it?
More or less, yeah. But it's just getting used to it. Okay. The second one, if you look at it, you have 3 over x squared minus 1. Okay, remember your vertical asymptotes happen where the denominator equals 0. So that'd be x squared minus 1 equals 0. Add 1, square root it. So you have asymptotes at negative 1 and positive 1. Right there, see that? And since your degree of your numerator is less than your denominator, 0 versus what, 2, right? Then you have a horizontal asymptote at the y equals line. Okay, make sense? Case 3, let's see, what is it? 2x plus 1 over x minus 3. Denominator would give you the horizontal or the vertical of 3. And since the degrees are equal, it becomes a ratio of your leading coefficients, top over bottom. So leading coefficient of the first one is 2, or the numerator is 2. Leading coefficient of your denominator is 1. So then your horizontal asymptote is the line y equals 2 over 1, which is 2. Hence why the asymptote is right there. So number 1, we're going to graph f of x equals x cubed over x minus 1. Okay, and like I said, I'm going to kind of, I'm not saying spoon feed you, but I'm going to kind of walk you through here, okay? So step 1 for any of these is to find the zeros. Okay, and that's where your numerator equals 0. So x cubed equals 0, which means you cube root both sides, so your 0 of x cubed equals 0 gives you 0 at 0. Okay, so we don't know what all happens with this graph, but we know that it's going to cross right there at the origin where x equals 0 at. All right. Everybody good so far?
No, I don't get it.
Remember that first paragraph?
Yeah.
Where it said, the zeros were across the x-axis? That's where your numerator equals 0. So that's what I did. I took the numerator, set equal to 0, solved it. Alright? That's step 1. Step 2, your asymptotes. Can you see that? Okay, let's do your vertical asymptote first. Vertical asymptotes come from where? No. No. Vertical asymptotes come from last lesson. Think about it. The denominator. Yeah. Okay. Your vertical asymptotes always come from your denominator where it equals 0 at. So x minus 1 equals 0. And then you solve that guy, so add 1 to both sides. So you have a vertical asymptote at the line x equals 1. Which is what type of line? I already told you that. It's a vertical line, right? Bless you. And again. Okay. So there's your vertical asymptote. Alright, now for your horizontal, whoops, guess what? that ain't going to work. Anyways, let's try that one more time. For your horizontal asymptote, there we go. You got to tell me which one of those three you're in. Okay, so for your horizontal asymptote, you look at your degrees. Okay, so your numerator degree is 3, your denominator is 1. So your numerator's degree is bigger than your denominator's degree. Alright, and this is where you guys have to kind of get used to, then what does that mean about your horizontal asymptotes? There isn't one. Okay. So no horizontal asymptote. If there was one, and eventually today there will be, you would state what it is. Okay? Yes?
I just tried to abbreviate horizontal and I just put the first 3 letters and I decided I needed a little bit more.
You should probably at least put the first 4. Or skip the second one. Alright? Step 3. Graph it. Okay? Step 3 is the graph. Now your graphs for these are going to be weirder than anything you've ever seen before. Okay, they are. Okay? They're going to be way different than anything that you are used to at all. Get a general shape, but also still go through your table and make sure that there's like different points that you should be looking for. Alright, I'm going to draw you the general shape here in just a second.
Mine's saying error.
You have to use the exercise one.
Yeah. That and then it says field range. The sensitivity of the variable function variable.
And there's a general picture of it, okay? Oh. Not exactly a straight line, but you get the point. Everybody gets it there? Vertical asymptotes. Okay. You got it factored right, x negative 2, x equals negative 2, and x equals 3. Okay. Okay, once again, you have a horizontal asymptote with your numerator bigger than denominator, which means you have none. Alright. Plug them into your calculator, go to your table, look at the general shape. This you should have plenty of nice points with. Okay, you should have one at negative 3, negative 3. So right there, negative 5, 6 it looks like. Negative 5, negative 6, thank you, yeah. 0, negative 6, I think, right? So, whoops, right there.
This one looks more similar to the other thing.
So like the other day.
Should we draw in our vertical asymptote?
Yeah, yeah. Drawing, yeah, I want to see.
And do it a dash line?
Technically, when you draw asymptotes, they are, yes. I know it can be a little bit of a pain for you guys to draw asymptote lines.
I think it's easier if we do a dash.
That's fine. I would rather see you do a dash, to be honest, or maybe a different color. Okay. But then you get into the different colors, you get into the pens and the markers and the permanent stuff, and then you're like, oh crap, a little more pressure because I can't erase anymore. Okay, Mitchell.
Is it okay if I paint in some?
Did you know
Okay.
that a rational function has an equation of the form x over bx, and they have to be polynomial functions, and 4 is not a polynomial function.
Yeah.
Sure it is.
It's not.
Sure it is.
We'll flip.
It's not polynomial.
Yes, it is.
How?
What's this? Shh, I challenge you. Fifth chapter, people.
0x plus 4.
What's this degree?
1.
No.
0.
Degree is 0. What's the leading coefficient?
There isn't one.
1.
Yes, there is.
4.
What?
6.
This is a polynomial function right there, kiddos.
No, it's not.
Yes, it is.
So you should just put it, there's
I
no
do
numbers. So I guess all graphs. They have a division bar.
I'm just gonna
Or what are these called?
take
Rational functions.
Essentially, yeah.
Yeah. So.
Because
So every
rational.
I want to hear you lie to us.
Oh, is that? So that's just what we're getting to. So that's what we're getting to, right?
Yes, that's
Okay.
exactly what
Now, so if we're paying attention to that slide, then go back to this slide,
Which one is this?
Your
the top one, the big one.
Okay.
Okay. If we're gonna pay attention and call me out for being a liar, then hopefully we're paying attention here. Okay. Now, I read from the 4th bullet down. If the degree of a of x, which is the numerator, is less than the degree of b of x, which is the denominator, the horizontal asymptote is the line y equals 0.
What the?
Do we recall?
Yes.
Okay, great. Now, what is the line y equals 0?
this graph is something.
The x, listen. The line y equals 0 is the x-axis. If you're going to get a 0 of a function, it has to cross the x-axis.
Sure.
So, in this case, there are no zeros.
Wow.
Because, there's no zeros for 2 reasons. Number 1, because you have an asymptote on the line y equals 0 where your zeros come from. That's number 1. Number 2, there's nothing to solve for in the numerator.
We figured that one out. Already.
Okay, I'm glad. I'm pretty sure that's why everybody got thrown for a loop. So, for this thing that I made,
Yeah.
step 1, for your zeros,
Don't do it.
none.
So that's good. Okay.
Well, that's
Well, ain't that
glad we had that discussion.
ain't that great?
It wasn't pretty either.
Well,
Okay.
I feel like you just
Shh.
want to do more
Holy
work
crap.
here to prove
Also,
your
is there no
right.
asymptotes?
Shh, shh, shh. Oh, ho, ho, I didn't say that.
Yeah.
Okay? Now, asymptotes are a different deal on this guy. Okay? So let's talk asymptotes. Okay, remember, your vertical ones come from what? The denominator being equal to 0. So x plus 3, x minus 2, x equals negative 3. I wasn't having a creative day. X equals 2. All right. So you have vertical asymptotes at the lines x equals negative 3, which is here, and x equals 2, which is right there. Your horizontal ones, okay, since the numerator is now less than the denominator,
Y equals 0.
your horizontal one is y equals 0, which is the x-axis,
Do we have to draw?
which is right there. I won't even know. You're right, unless you're going hard with it, like, you know. So then, yeah, I don't need to. Okay, as long as you don't cross it.
Mormon, there
Don't-
should be an arrow on both sides of that line. Or it's not a line, it's a red. Thank you.
Now for this one, as you guys probably already have, and if the first thing you do, I'm not getting heartbroken if the first thing you do is put this in your calculator. That's fine. Just make sure whenever you do it, group it correctly. Especially and this goes when we get into more complicated ones, doing the numerators and denominators. Okay, if it's a binomial top and bottom, make sure you group it in your calculator. Otherwise, your graph will not come out correct. So this one's graph, if you looked at it already, is quite possibly the oddest thing you have ever seen in your life.
That's me if I was there.
Hey, how's the horizontal asymptote 0? And it's not even like
All right, do your zeros first. So numerator. So 3x minus 3 equals 0. Add 3, divide by 3, x equals 1. So you should have a 0. Did I? Ah, my fault. Boom. There. Whoops, go away.
This image is small.
So there's 0 there at x equals 1. All right, so now, listen. Asymptotes. You get your vertical from your denominator, so x plus 1 equals 0, which means you have a vertical asymptote at x equals negative 1. So it's right there. Okay, your horizontal. Now, your horizontal, in this case, your numerator's degree equals your denominator. So whenever that's the case, your horizontal asymptote is the ratio of the leading coefficients of your fraction. So the leading coefficient of your numerator is 3 over 1. Okay, so basically the line y equals 3. I'm going to write it as 3 over 1, though. That way when you guys go back, you know why. Which puts, whoops. It can be, yeah. Okay, step 3 is to graph it. Alrighty, let's see. You have a couple of nice points in the left side one. It looks like at negative 3 there. It looks like at about right there, I think. I don't know, I'm guessing on that one. Which goes like that. Okay, and like I said, I'm looking for closeness, so make sure, like, for example, if you graph it, you'll notice it's not, like, right up against this corner, so don't draw it over there. Okay, get it about where it should be if you guesstimated it, okay?
Mormon,